Hello friends, welcome to my channel, that is IGNOU MCA, and today's topic is interruption and the instruction cycle we have discussed earlier with interruption, right? So we are reading interruption because that is an important process in any computer architecture. And suppose you are reading something and your mind goes through some other topics, right? So that is called interruption, because those other topics are interruptions. Just like that, computer architecture also has some interruptions, and we need to know in detail about this so that our future studies will be more comfortable and the learning curve will be proper, right? So without wasting any more time, let us get into the topic. And quickly I want to mention that if you like my video, please subscribe my channel, as well as please comment what type of video you want to see from my channel. And if you like it, then obviously like this video. Okay, thanks for watching this. So first of all, we will discuss what is interruption, right? So let us do that. So what is interruption, or maybe we can say interrupt, right? Interrupts. The term interrupt is an exceptional event that causes CPU to temporarily transfer its control from currently executing program to a different program, which provides service to exceptional event. So that means, let's say this is a CPU chip. Actually, sorry, I have done a mistake here. Okay, so let's say this is a computer chip or CPU, and it is actually working with some programs, some instructions, and that time interrupt happen. Suppose say the CPU was handling couple of programs, just like this is a instruction 2, this is instruction 1, and also it was managing some main memory concept. So suppose from main memory the CPU got an interrupt. So suppose main memory calls CPU that we are facing some issue. So what CPU will do? So CPU will tell this interrupt to meet with ISR. So what is ISR? We'll right now talk about it, and this ISR will create a fix for this interruption, right? So so what happens? So when it gives some fix to this interruption will measure it, and in the meantime CPU can manage its own work. So that is the main concept behind interrupt or interruption. So now we will talk about what is ISR, or we can say interrupt service routine. So what it does mainly, suppose if a interrupt actually interrupt occurs, then it has specific fix for the interruption. So actually interrupt service routine, what it does, it has some fix built in, so that when a interrupt actually happens, what it does, it actually use that fix and it actually resolve that issue, so that CPU or any other element which is working on something to give us result, that can do its work without any interruption, right? So this is called ISR. So once we have discussed what is ISR and interrupt, so let us wipe this and we will now talk about some different things. We'll know more details about interruption. So what is this actually? So we'll now discuss about some interrupts and reason behind their interruption. So interrupts and reason behind that. Okay, so first of all, the interrupt we will talk about, that is just let it be easy, that is interrupt generated by executing programs. Now once we are discussing this, then let's just focus on that matter. So this actually happens for some reasons, just like while we are, so division by 0 is the reason. So suppose we are giving a command, and by mistake in that program there is the option actually goes for division by 0. So if something happens like that, then interruption actually occurs. This type of interaction actually occurs. And the next thing is the number exceeds the minimum limit suppose we have created a program where we need to put some numbers. Suppose we need to enlist 6 students, and sorry, not minimum, actually this will be maximum. So this will be something like maximum, right? So maximum limit actually. So let's just say our program can execute 20 students documents together, but we have actually exceeded the limit. Then it will create an interruption in that scenario while we are executing this, right? And the next thing is next reason behind this is using illegal privilege instruction. Illegal privileged instructions. So how is that? Suppose we have defined an instruction for private users, but we are using that on a local variable. Then this type of interruption happens. So if we have actually secured that instruction earlier, then we need to use our codings like that, so that no interruption will happen. Otherwise this type of interruption generally occurs. Also there is another reason, the last reason for this type of interruption while we are executing any program. That is, suppose we have allocated some memory somewhere, okay, but it is a specific memory address, and suppose our program actually stores data on a different memory. This is memory 1, and suppose our program actually stores data in memory 2. Then this type of actually interrupts happen. So mainly 4 reasons are there for this type of interrupt, that is interrupt generated by executing some programs. While the division by 0, this type of actually interrupt happen even if the number exceeds the maximum limit, as well as using illegal privileged instructions, right? And if we have allocated a memory and our program actually stores data in another memory, then this type of interrupts happens actually. So let's go through the next interrupt or interrupts actually. Okay, so let's just check that. So next interrupt is interrupt generated by processor or clock. interrupt by processor, right? So when this type of interrupt actually happen, only one for this interruption, actually one reason is there only. So in multi-programming operating systems, if allocated time expires, then this type of interrupts happen. Suppose a program, a instruction supposed to happen to execute within 4 seconds, but it failed to execute in 4 seconds by processor, then this type of interrupt actually happen, right? And the next interrupt, let us talk about that also. Okay, so next one is interrupt generated by input output device. So interrupt generated by input output device, this type of interrupt actually happen for three reasons. One is for requesting input or output operation. Number two, okay, after taking the input or output, or maybe printing the output, after printing output, it will also halt the process to ensure everything. So that means normal completion of an input output operation. So this is a reason also, and the third reason is occurrence of an error in input output. So error in input output. So actually there is three reasons for this type of actually interrupt. One is for requesting input output operation, one is normally completion of the input output operation, and the third one is if we are doing this and this on that time we have made an error, then also this type of interrupt happen actually. So let us move through the next topic, that is next interruption. What is that? And let us talk about that also. That is interrupt on hardware failure. So on hardware failure, right? So why this type of error happens? So this type of interrupts happens generally for two reasons, as you can understand from the interrupt name at itself actually. So when we face some power failure, and the second one is memory parity error actually. Memory So these are the four interrupts. They are let me go through this. First one is interrupt during executing some programs. That actually happen for four reasons. Division by 0, the number exceeds the maximum limit. Using illegal privileged instruction, referring memory location other than allowed for that program. And don't worry for notes, actually notes are in the description, right? So don't worry for notes, I have already created notes for you guys so that you can read the notes from description. And
the notes will be the same notes which I'm actually discussing, because that will be familiar with you guys. And the second interrupt is interrupt generated by processor or clock. So this type of actually error happens when in multi-program operation system, if allocated time expires, when this type of then this type of interrupts actually happens. Input output interruption happens for three reasons: request of starting an input output, normal completion of an input output, and occurrence of an error in input output operation. And third one is interrupt on hardware failure. So this happens for two reasons: power failure and memory parity error. Okay. Interrupts are useful mechanism to improve efficiency of processing. Almost all the external devices are slower than the processor. Therefore, in a typical system, a processor has to continually test whether an input value has arrived or a printout has been completed, in turn wasting a lot of CPU time. Wasting a lot of CPU time, right? With interrupt, CPU is free from the task of testing status of input output devices and can do useful processing during this time, right? Thus increasing the processing efficiency. And now we will in detail we will discuss about interrupts with instruction cycle. So
now we will try to understand the interrupts with instruction cycle. So first of all, we'll take a look at our first step, that in our CPU this type of complicated process actually goes through. Although this is not a complicated process, it actually needs our intention to understand all of it so that we can know the interrupts and instruction cycle process better. So first process is the program execution complete? If it is completed, then we'll go to this block, that is ISR is over, start the interrupted program again. So if interruption happens actually, then first of all we'll check if the ISR is over. That means the fix has been already done on that app. If it is done already, then we will resume executing that app again. If the program is over, then if the program that we want to execute and that creates a interrupt, if that is over, then we'll move to another app. As we have already known that here the program actually executes sequentially, that means one after another, right? So the next thing is that if it is the no, that means if the execution is not complete, then what we'll do, we'll calculate the address of the next instruction, so that our work will goes on and processor will not be on hold. And then from that we'll fetch the instruction. After that we'll decode the instruction, and then we'll try to calculate the operand address. Then we'll again fetch the operand. After that, if the more operands are needed, then we'll again go to decode instruction situation, and we'll try to fetch more operand details if we need. If not, then we'll perform the calculations which we are intended to do on the next programs, and we'll store result. This thing will be done in the memory. After that we will check if there is any interrupt or not. If there is no interrupt, then the program will be executed. If there is some interrupt, then we'll again go to this block. This block says acknowledge and process interrupt by saving context and disabling lower priority interrupts. So here in ISR we'll check which is the lower priority interrupt and which is the higher priority interrupt. Suppose we are having some interrupt regarding power issue, that means for power error we are having some error. So that is the major error. If it is having some power error, then it cannot run any other instruction. So in this way, in ISR it will check that the priority level, and then it will go for the higher level interruptions. Okay, and it will first execute the most prior interrupts. Then it will go gradually to lower priority levels. Load the address of first instruction of the selected ISR, and it will then load the first ISR instruction. As I said, the first priority level. then again lower priority level gradually. Okay. Also, if the program execution is complete, if it is no, then also we'll check for interrupt. So that is why I actually made this in red color, so that we can easily distinguish between the lines, as well as I also want to indicate that the arrows does not overlaps actually. Okay. So thanks for watching this video. If you like my video, please comment, share, and press on the bell button also, so that you will get continue update from my channel and about the video contents. And let me know in the comments what are the hard topics you want to know from my channel. I will obviously try to create a video for that. And thanks for taking this course. Have a nice day.